Hi, I'm Ben the Tutor. Today we're going to talk about some more sequences in series. I've already done some videos on arithmetic sequences in series, and today we're going to do geometric sequences in series. Okay, so with these kinds of things, the first thing is, what the heck does geometric sequences in series mean? So, arithmetic is where you're adding 2, 4, 6, 8, 10. Geometric is where you're timesing by a certain number. 2, 4, 8, 16, 32, 64. So that was with the number 2 timesing. Okay, so I have on the board here a geometric sequence. And if you look at it, it says 3, 6, 12, 24. So let's think, what number am I timesing by? I'm timesing by 2 each time. So I'm going to just do 2 more. So 24 times 2 is 48. And the next one is 96, and so on. So a geometric sequence has timesing. It's timesing to make it bigger each time. So here is the formula for a term. Tn equals T1 times R to the n minus 1. You might have seen it written as Tn equals A times R to the n minus 1. They're the same thing. So T1 or A is the first term, and R is the number you're timesing by each time. So in this case, T1 or A is 3, the first term is 3, and R is 2, because each time I times by 2. So I'll put these numbers into the little equation. So we get Tn equals 3 times 2 to the power of n minus 1. So with this equation, I can calculate any term all the way down. So remember about n. N is the index, and it's like the name of each term. So we can call the number 3 T1, and we can call the number 6 T2, and the number 12 T3, and the number 24 T4, and the number 48 T5. So the first term and the second term and the third term. And it's important to remember n is the name, and Tn is the number that it is, and n is the index. It's the first one, the second one, the third one. And that's what n is. Okay, so using this equation, I could calculate, let's say, the 20th term of this. So if I wanted, I could just keep timesing by 2, or I can use this guy. So T20 equals 3 times 2 to the power of 19. That's n minus 1. And if you put this into your calculator, you'll get, I wrote it down, 1,572,864. That's 1,572,000. And you should probably try doing that in a calculator so you can make sure you can learn how to do exponents. 2 to the power of 19. And remember, exponents first, timesing second. Okay, so there is one example. I think we'll try and do 4 examples. Okay. There's my magic erase button. So I have another example here. 50, 25, 12.5, 6.25, and so on. Okay, so in this example, we're timesing by something, but what we're timesing by is making it smaller, and that's totally allowed. So here R is actually 0.5, and T1, the first one, is 50. So Tn is 50 times 0.5 to the power of n minus 1. I'm just following the formula. Tn is T1 times R to the n minus 1. Okay, so let's try practice 1. And my practice 1 will be T15. So what's the 15th term? And let's try it. So it's 50 times 0.5 to the power of 14. And if you plug that into your calculator, you should get something like 0.00305. So every term gets smaller and smaller and smaller, and they keep on getting smaller and smaller and smaller. Okay, two more examples. How about this one? -4, 8, -16, 32, and so on. So this one's interesting because it's got negatives and it's swapping back and forth. I wonder if you could think about what the difference is, the timesing number. So you think about just the numbers, 4, 8, 16, 32. So it's timesing by 2, but because the negatives are swapping, it's timesing by -2. So R is -2, and T1 is -4. So Tn equals -4 times -2 to the power of n minus 1. So why don't we figure out, say, the 10th term, T10 is -4 times -2 to the 10 minus 1. So -4 times -2 to the power of 9. And if you put this into the calculator, you should get 2048. Okay, so those are the basics of the geometric sequence. Now, I said I would do 4 questions, and I will do one more question, and this one's a bit trickier, actually. So, say let me get my numbers down. I had this. T2 is 12, and T6 is 972. So I don't have a list. All I have is the 2nd term and the 6th term. And it wants me to find out what is the 1st term and what is the R, so I can write down the whole thing. Wow, this is a little bit tricky. But I have 2 numbers, and each of them corresponds to an equation. And there's a kind of a trick that you need. So let's try. So let's start out, let's remember Tn equals T1 times R to the n minus 1. So for T2, I know the value is 12 on the left side, and I know the n is 2. So I'm going to write 12 is T1 times R to the power of 1. So T1 and R are still, I don't know them. They're still variables that I haven't calculated. But I have some equation, and I'm going to use the second one and do a similar thing. So T6, so 972 goes on the left side. 972 equals T1 times R to the n minus 1, so R to the 5. Okay, so now we have to do a move. There's a few ways to go about this, but I like doing a move which you might not have done before, but you take the equations and you divide them to each other. That is, you take the left side and you divide the left side by each other, and then the right side you divide the right side by each other. So the left side is 972 divided by 12, and the right side is T1R5 divided by T1R1. Okay, I'm going to write that. So 972 over 12 equals T1 R to the 5 over T1 R to the 1. And the reason I do this is because I want to eliminate a variable. I'm going to eliminate T1, and I'm going to get a little equation with just an R in it, and I'm going to be able to solve for R. So this is the move, the trick, and you need to know how to do a trick like this. So I now have an equation. The left side is 972 divided by 12. And if you put that into your calculator, you'll get 81. And on the right side, T1s cancel, and R on the bottom cancels, and R to the 5, I need to minus an exponent. So I get R to the 4. R to the 5 divided by R is R to the 4. Okay, and so 81 equals R to the 4. That doesn't look too complicated now, actually. I go quad root each side, and I get 3 equals to R. And you can put that in your calculator to check me. So I now have R, and I also want the first term, T1. So I'm going to use T2 in this equation here. So 12 equals T1 times R to the power of 1. But I now know R, so 12 equals T1 times 3, and I divide by 3, so T1 equals to 4. So the first term is 4, so, and the difference, or the timesing number is R, the ratio, that's what we call it, the ratio. So I'm going to start, I'll just draw this out to show you what the whole thing would look like if we did a few terms. So 4 is the first one, we times it by 3, so we get 12. That's the second term. Times it by 3, we get 36. Times that by 3, we get 108. Times that by 3, 324. Times that by 3, you will get 972. And that's T6, like we said. Okay, so that's an introduction to geometric sequences. Thank you very much for watching. I hope you enjoyed this video. Please do give me any feedback or comments, and make sure you have a nice day.